So, last class we have considered the one problem that we have a one point is fixed and other point is free. Again, the point A is fixed and point B is free. So, what we have considered, let us, our problem is that this is the functional which is T 0 to T f, this functional we have to optimize, either minimize or maximize. What should be the choice of the trajectory x t, so that this functional is a maximized or minimized. So, let us consider the x star is the optimal trajectory and its point A is fixed, B is free. It may be free in time and may be fixed in the end points of x. Now, near neighboring of this trajectory, we have considered another trajectory, that x star delta of x t, that is x a, and this trajectory is, we have assumed A, that is D C, this trajectory, and whatever the notation we have used it, the same notation what we have used it earlier, considered here. And what is we have to do? First, we have to find out the what is called our first variation of the functional value del j, change in or incremental change in functional value, this, and this T 0 to T f plus delta T f, because T f is free and x T f also free, x value, final value of state also free. So, this we can split up into two parts, T 0 to T f plus T f to delta T f. So, what we did it here, we did exactly same, T 0 to T f and delta T f to delta T f plus delta T f. Now, this part and this part we have already simplified in earlier. So, there is no problem with these two parts, and these two parts will give you the condition for Euler's Lagrange equation. Now, what about this one? So, this we will see, it is nothing but a, let us call this is the functional B, and it is the integration from T 0 to T f. Let us call T f is there, T f delta T f. So, area under this curve. So, how we are approximated this integration term, ultimately we have explained earlier, ultimately we have approximated that integration part by this one. That means, it indicates whatever the slope at this point T is equal to T f V of x t curve, that V of x t curve, that this is the V of x t curve, take the slope of this one, agree, then multiplied by delta T f. At t is equal to T f, find out the functional value and multiplied by T f. So, this is the approximate value of what is called this integration part, when T f is very small, delta T f is very small. So, using this expression in equation, this expression, this approximation we did it by this one. Using this expression here, then we will get it finally this expression. And I told you, if you consider, I told you earlier, this and this we can simplify as we did earlier by this term, agree, this and this term. So, last term we have simplified this way, that is middle term of this increment of functional value is approximated this one. And now, see this one, this term t is equal to T 0 delta x T 0 is 0, because this is a fixed point, but T f at delta T f T f delta T x delta x T f is not 0. So, further we can simplify this one, that we will discuss now. So, if you see this one, that that same expression I can write delta j nearly equal to T 0 to T f and delta del v del x of t, this one minus d of dt del v dot del x dot of this whole, then wholes bracket transpose at along the optimal trajectory this one, and delta x t dt plus del v dot del x dot whole transpose star means along the trajectory, star means along the trajectory, del x t. So, t is equal to T f, because delta x t is equal to T 0 is 0. So, that term we are not considering from the previous step, and these two terms includes the first term of incremental transfer function and third term of incremental transfer functions. That is, this indicates the after simplification all these things, this indicate that I told you incremental transfer function this term as we did earlier is the simplification, after simplification we got it that one, plus middle term of this one we have approximated the integration T f to T f plus delta T f v dt is approximated by take the slope of the functional at t is equal to T f, then multiplied by delta T f. So, this is T x t x star, or you whole thing you write it bucket, then complete the bracket and then put star whatever you like it. Then you evaluate this as t is equal to T f. Again find the value of the function at t is equal to T f, then multiply just like approximation by rectangular area we got it again this, and it is just if you recollect this one what we did it here, that find out the value of the function at v function at t is equal to T f. So, this is the ordinate, and that ordinate multiplied by delta T f will give you the value of the function, value of this curve when integration T g T f to T f plus delta T f. It is approximation is valid when delta T f is small. Okay. So, that what we did it here. The next is, let us call this is equation number 4. We have considered up to equation number 3. Last equation if you say we have done up to equation 3 this one. So, this is equation number 4. Now, look at this expression of this one, that we have a use this lemma as we discussed. The important lemma is T 0 to T f g t delta x t dt is equal to 0 if and only if g t is continuous and it is 0 at every point over the interval T 0 to T f. That if and only g t is 0 at every point over the interval T 0 to T f. So, we will use this lemma in this equation 4. So, this part will be 0 provided this is 0, because I have to necessary condition for the function to be optimized is delta j must be equal to 0. First variation of the functional must be 0, this is the necessary condition. So, using the lemma in 4, we get del v del x t minus d of dt del v dot del x dot of t whole is equal to, you can find out, you can put all these things is star, or because I have to find out the optimal trajectory of this one, or you solve this one, whatever the solution of x you will get it, that will give you the x star. Either you can put whole thing star or omit this one, and this dimension is n cross 1. If x is the vector whose dimension is n cross 1, that n variables are there x 1, x 2, x 2, then the dimension is this one. So, and in addition to this, this must be 0 in order to make this is that. So, our in order to make this is del j is 0. So, if this is 0 in the expression 4 boils down to that one, that nearly equal to del v del x dot of t whole transpose delta x delta a, because del j is scalar quantity. This is a row column vector. Now, you have to take transpose of this one when you write it this one, and this you have to calculate t is equal to T f plus b dot v t x star of t x dot star of t whole t is equal to T f into delta T f, and that what we can simplify that one we can see here. So, now look at this expression for that one, what you can write it for this one. Refer to our original figure. T, this is A, this is B, this is T f, this is T 0, and this is our D, and this is our C. So, as this and this value is, if you see, this value is our delta x T f, and from here to here, if you recollect that this is our nothing but a delta x, this is at C, T f plus delta T f, agree, and that we denoted by delta x f, agree. So, this is x of t 0. Now, see how we can write it. Delta x of f means value of the function along the x a of t near, this is x star of the trajectory, and this is the x of t is equal to x star of t plus delta x of t. So, this one is nothing but a this one, this length of this one, this length plus this length. So, I am writing it this delta this, that delta x T f plus find out the slope at this point multiplied by delta T f, what is the incremental. So, x a dot of t, find out this derivative at this point, okay, and that at t is equal to T f into delta T f. So, this expression I can write it. Now, which in turn I can write it delta x T f, this one is equal to delta x f minus x a dot t, t is equal to T f delta T f, agree. So, this expression we will use in equation number 5. Let us call this is the equation number 5 for our case. This is the equation number 5. This is the equation number 5. So, and this is the equation number 6. Using 6 in 5, what we get it? So, let us write it 5 delta j nearly equal to this term as it is, we will write it that v t x star of t x dot star of t, that bracket comma t is equal to T f. Second term of expression, second term of equation 5 is this one plus, but delta T f is there, delta T f plus first term I am writing now del v dot del x dot of t, that transpose this as t is equal to T f, t is equal to T f, and we have a this delta x T f. That this thing I first put the value of this one, then this you can do it, put this value, this is the at t is equal to T f, you put this value in the gradient transpose, gradient of v with respect to x dot, its transpose, you put this value and then multiplied by x, t is equal to T f, that is what we did it. Then this one, this expression in place of T f, x T f, this I will put this value here. So, if you use this value here, then we will get it delta j, we will get it delta j nearly equal to v t x dot x star of t, then x dot star of t bracket close t is equal to T f into delta T f, that is first term as it is. Second term of first part we will write as it is, second term of first part we will write as it is, and second part we replace delta x T f is equal to delta x f minus x a dot of t, t is equal to T f. That means, find out the slope of the neighborhood trajectory of the optimal trajectory at, find out the slope at t is equal to T f, agree, then multiplied by delta T f. So, this is the second part, I have replaced x delta x bracket T f replaced by that one. So, now see this one, what is note, just note what is x T f delta dot x T f is equal to x dot T f star plus delta x dot T f, this one. So, I will put this value in this equation, and if you put this value in this equation, you see delta x dot T f, this and delta x T f multiplied by T f. So, this is a small quantity, again it is a small quantity, the second part is omitted, neglected. So, what is leftover term is here after putting this expression T x star of t into x dot star of t, t is equal to T f delta T f plus v x dot of t whole transpose this, and this is as it is that one delta x f, and this term x dot x a dot t, x a dot t is the trajectory neighborhood of the optimal trajectory, that one. Okay. At this point you are finding out the slope multiplied by del. So, if you put this one, this will be replaced by this one multiplied by delta E f. So, this term delta x dot T f multiplied by delta T f is neglected. So, it will be left with x dot star T f. Okay. Now, we can what we can write it, just see this one delta T, and this is multiplied by this one multiplied by delta T f, that is I missed it here delta T f, then bracket close, because this one multiplied by delta T f. So, delta T f I will take common, then you will get V T x star of t x dot star of t, agree, bracket close, minus del V del x dot of t whole, agree, this star multiplied by x dot star T f, this, because delta T f is common in both the expression, this expression and this expression delta T f, plus leftover term is del V x dot t gradient of B with respect to x dot whole transpose star, agree, into star into delta x f, this one, agree. So, this is the equation. Now, delta j will be 0, delta j if you impose the first necessary condition is the assigned to 0, will give you the optimum value, the point what is called solution of this trajectory will give you the optimum value of the functional. So, in order to make 0, when delta T f is not 0, this must be 0. If T f delta T f is 0 means final time is fixed. On the other way, delta x f is arbitrary, that means x f, the final point of x is arbitrary, then delta x f is not equal to 0. So, in order to make that is delta g 0, this term must be 0. But if it is fixed, that is end point of our trajectory is fixed, x f is fixed, but T f is free, then this one will be 0. Okay. So, now let us see what is the condition can impose in order to make delta j first variation of the functional assigned to be 0. If the variation delta T f and delta x f are arbitrary or arbitrary, we obtain delta j is equal to 0 if we assign that V t x of t x dot of t minus del V del x dot of t, this one whole transpose x dot of t, and this value you see when delta T f is not arbitrary, then this cannot be 0, this must be 0 in another time makes. So, this equal to 0 at t is equal to T f. So, here I forgot to write, you see this is T f at t is equal to T f, this is also you see x t is equal to T f, agree. This whole term you see this is T f at t is equal to T f, agree, and this is also at t is equal to T f. So, we can write it here at t is equal to T f, this one, this I missed here, and next is this will be at t is equal to T f. So, if you put it this one here you see t is equal to T f from there, here I missed it this one. So, this into T f. So, whole thing I can write it that whole this and t is equal to T f. So, this equal to 0 when delta T f is not equal to 0. In other words, T f is free. Another condition, if x f is free arbitrary, then this is not equal to 0, this assign we can assign it equal to 0. And another condition that delta v dot delta x dot of t star t is equal to T f is equal to 0. Agree? So, we have used the equation up to 6, let us call this is 7, this equation 7 and this equation is 8. And when this is true, that delta x T f x f delta x f is not equal to 0, it means that x T f is free. Okay. So, equation 7 and 8 commonly known as that equation 7 and 8 combinedly known as or called as transversality condition. This is the important condition. So, what is our conclusion? If you have a problem is like this way, if you have a, see this one, if you have a j is a functional, you have to optimize this functional, then what should be the choice of our optimal trajectory x t, so that this function will be optimized. Then we have considered one point is fixed, other point is free. When time is free, x t f is free, both are free. Then what we obtain first, in order to the necessary condition for this one is delta first variation of the functional must be 0. In order to assign that functional first variation of functional 0, first condition is the our Lagrangian, what is called Euler Lagrangian equation must be assigned to 0, that is Euler Lagrangian equation, that is you have just what is the that is your is del v del x minus d of dt, del v del x minus d of dt is d of dt bracket del v del x dot is equal to 0. This is Euler's Lagrangian equation must satisfied. In addition to this, there are two conditions are there when both the points, that means time and x t f are free, then these two conditions must be satisfied. That condition are called transversality conditions, and this is the condition that equation 5, agree, that this equation must satisfied. So, one end is fixed, other end is free. In order to optimize the functional value, agree, j is the functional, we have to optimize, we have to satisfy first Euler's Lagrangian equation, this equation. And in addition to that, there we have a terminal condition, this 7 and 8. These terminal conditions are called, end conditions are called the transversality condition. Simultaneously, we have to solve equation number, this equation and the end condition, using end condition we have to solve. That means, we will get a trajectory, optimal trajectory for this one. So, next is that what is called, if you summarize this one, the results for this one, that what we have mentioned this one, we have a functional, this is T 0 to T f v x of t x dot of t dt. one end is necessary condition. We have assumed one end is fixed, refer to our earlier figure, one end is fixed and other end is free. So, first condition of this one, in order to make first variation of the functional, that first condition is del v del x of t minus d of dt, take the gradient of this with respect to x 1 dot, this equal to 0 whose dimension is n cross 1. So, whole bracket star you can give, because ultimately this equation you have to solve it, not necessary to put it star. It indicates, the star indicates that if you solve this equation, whatever the trajectory you will get it, that is the optimal trajectory. That functional value may be maximum or minimum. At this stage, necessary condition will give you the what trajectory will make the functional value is maximum or minimum. That means, sufficient condition one has to check it. The next, this is the one condition. Next two conditions, the end condition you have to use for this problem is the called transversality condition, that v dot of x del v dot del x dot of t whole transpose x of x dot of t, this put t is equal to T f is equal to 0. And this condition, if you see this one, this condition are achieved from this condition. That means, when T f is free, when T f is free, this condition must be satisfied. So, you whether you give it star or not, it does not matter. You have to solve this differential equation with this final condition, this. So, this is the one condition, and the next condition is that del v dot del x dot this t is equal to T f is equal to 0. So, let us call equation number 1, equation number 2 and equation number 3. This is valid when T f is free. T f is free, that means, delta T f is not equal to 0. This is true when delta x f, or you can say x T f is free, implies that delta x f x t x delta x f is not equal to 0. So, equation 1, 2, 3, equation 1 you have to solve. In order to solve the equation, you need the end condition of equation 2 and 3. 2 and 3 you have to use it. That two things combinedly I told you earlier, transversality conditions, transversality condition. Agree? This is called transverse 2 and 3. So, so now we will we take different cases, you know this one. If you consider the case A, let us consider case A. What is the case A? Case A is when both T f and x T f are free. We need to solve 1 to 3. these three equation you have to need to solve. One, we need to solve one to obtain optimal trajectory x star of t. X is the n dimensional case, then this case t. Then you know both the ends it is free. That means, corresponding figure if you see, this is that one A, B, and this is D, this is C, this is T 0, T, T f, this is T f plus delta T f, agree, and this point is, you know, this is x star, this trajectory, and this is x a of t, which is equal to x star of t plus delta x of t. So, when both are free, then you have to use equation number 1 and 2. Then some special cases can be derived from general case P, general case A. When T f is free, but x T f is fixed. This is fixed. That means, this corresponds to curve is like this way. Suppose this is, you consider x star of t, neighboring node of this one, or near very close to this optimal trajectory, there is another trajectory x of t is equal to x star of t delta x of t. So, you see x t f, this is the x t f. So, x, this is fixed, that means, x t is equal to this is fixed, again that is fixed. But T f and that is a T f plus delta T f. You just consider this situation like this way, that our at time t is equal to T f, this trajectory must reach x T f value. This at time t is equal to T f plus delta E f, that very neighborhood of this trajectory also should reach at this fixed value T f. What is the T f value is? It should reach to same value. That means, x T f, this is x T f plus delta T f. This must be equal to 0. Both the value is same, this one. So, in this case, you see this condition, that means, x T f is fixed, x T f is delta T x T f, you say delta x T f is what here, you see there delta x T f is 0. So, this condition will not come into the picture, only this condition. So, we have to solve equation 1 and 2 to obtain optimal trajectory, to obtain optimal trajectory we need to solve one and 2. Agree? Now, case 3 or case C, you can say case C, when T f is fixed, but x T f is free. The corresponding figure you can visualize like this way, T, this is x of t, and this is T f is fixed, T f, and this is, let us call that, and this is that one. this is you can say A, B, D. Agree? Here also if you want to give name of this one, this is A, B and this is D. Again this is x star of t, this is A of t. So, in this situation you see T f is fixed, means delta T f is 0. So, if you see this one, our that equation delta G expression, then delta T f is fixed, means T f is fixed, delta T f is 0. So, this term will not come into the picture in the end condition. So, this is not equal to 0, because x T f is free, delta T f is not equal to 0. So, this condition is 0. So, we need to solve to obtain x star of t optimal trajectory. X star of t means optimal trajectory. In order to make the functional value is optimized, we need to solve equation 1 and 3. So, more general expression is one can write, if you restrict the free end, that means point B restrict on a curve, then what will be the transversality condition corresponding to that point. So, case 5 or case D or 4, case D, when the end point B restricted to a curve G of t, agree? Then what will be? So, corresponding diagram, if you draw it here, this is x, this is t, this is x of t, this is point this, and our curve is G of t curve, the end, this is a point, this is the your B point is restricted on a curve, this one. So, our neighborhood of this optimal trajectories, there is another trajectory we assume, that one. So, that is our D point, agree. This corresponding to is D point and this is corresponding to C point. This is corresponding. So, this is x a t is equal to x star of t plus delta x of t. So, this is your what is called G of t. The end point of the trajectory restricted on the curve, which is the function of time, then what will be the condition, but our Euler's condition will remain same. So, now what we can write it for this one? See, this is our, if you look at this one, this is our T 0, this is T f and this is our T f plus delta T f, and this corresponding point is x T 0 is equal to x 0, and this point corresponding to this one x T f is equal to x f. Agree? So, we can write it delta x T f plus delta T f. Agree? That means, this here to here. Is this one I have denoted by delta x f, which is nothing but a delta x T f plus delta T f. Okay. This I can write it is equal to delta x f, which is same as you can say g to the g of t, take a tangent, make a tangent at the point of B. So, I can write it this nearly equal to g of t dot find at t is equal to T f multiplied by delta T f, that is nearly equal to, I can write it. So, x delta x c f I just replace by that one. Now, if you see this expression when we derive that one, that is okay, from the, we can write it from the first variation of the functional. We rewrite this expression once again. That means, from the first variation of functional, if you see that one, this expression I am writing once again for your convenience. Agree? So, delta g, or I have given you the equation number? No, I am not given. So, it is a del j is nearly equal to del v dot that star t is equal to T f delta T f, agree, that is t is equal to T f delta T f plus del v dot del x dot t whole transpose then star t is equal to T f into del x f minus x a dot of t is equal to T f del T f. Now, look this one, this value I will replace by what we made an approximation here, that is that we will replace it that one. If we replace that one, then it will nearly equal to v dot this star t is equal to T f delta T f plus v dot this transpose x dot of t whole transpose star t is equal to T f, and delta T f what will replace? Delta x f will replace by g dot T f. See, g dot at t is equal to T f, g dot T f into delta T f, and this expression, if you know, this expression is nothing but a x t a, x a t is nothing but a x t star plus delta x t f, agree. So, this is nothing but okay, I write it, that is x star T f plus delta x T f at t is equal to T f, that one into delta T f, okay, bracket close. Now, this equal to, so delta x of this term is omitted, this both are small quantity of that one. So, this I can write it now, if you see that v dot of star t is equal to T f delta T f plus this term is omitted. So, it will be a del v dot function of or gradient of v with respect to x dot whole star, then find t is equal to T f, agree. Then you can write it g dot T f minus x dot, this is dot, this is the dot because x a dot. So, dot star T f, agree, this one into delta T f, agree. So, this can further I can simplify V dot is equal to del V dot del x dot of T whole transpose, agree, whole transpose. If you want to write it star, you can write it here, star you can write it here, multiplied by x dot star of T minus G dot T whole, the whole bracket, because at T is equal to T f, T is equal to T f, mind this value you call at T is equal to this value you calculate at T is equal to this value you calculate at T is, just I change this I bring it first and this I bring it. So, minus sign has come here. So, into d f is equal to 0, this one. So, in order to make this is 0, in order to make this is 0, then delta T f you see in this case, that is what is delta T f is free, agree. So, this is not equal to 0. So, this must be 0. So, our condition for arbitrary delta T f is not equal to 0, our condition, the transversality condition case boils down to this way, V dot of this del V, the del x dot of T whole transpose x dot of T minus G dot of T, that this whole T is equal to T f, you can put a star, because it is a boundary condition. You have to solve Euler's equation, equation number 1 as we mention it here, that equation and this equation, when you free and restrict on a curve, that equation number 1 and 4 you have to solve. This is the equation number 4. So, this is also called transversality condition, for the case when the point, when the end point B is restricted on a curve x t is equal to g t, on a curve g t. So, in short, when the free end B is restricted on a curve g t and the another end is fixed, then we have to solve Euler's equation, which is equation number 1 and equation number 4, that we have to solve it. And now, question is, after solving this one, you will get the trajectory x of t, x star of t or x of t, which is the optimal trajectory, agree. Now, what will ensure that this trajectory will give you the optimal value of the functional, optimal means whether it will give the maximum value of the functional or minimum value, j will be minimum or maximum, that way. For that one has to check what is called the sufficient condition for this one. So, next class we will discuss the sufficient condition to establish the what is the functional value is minimum or maximum. So, we will stop it here at this moment.